So now what we're going to do, we're going to do functions, which is question 5, 6, and 7. And another thing is that I have completed the Gauteng paper 1 and paper 2 2021. Yes, 2021. I will completed them already. I'll link the playlist down in the description. So now let's start with functions, this question. So they say given g of x, then they give us the function. Then the first question says, write down the equations of the asymptote. So we need to write down the equation of the asymptote. Since this graph, right, is a what? Is a hyperbola. Hyperbola has two asymptotes. If it has two asymptotes, one asymptote is the horizontal asymptote and the other one is the vertical, right? So this one, see this one in pink is going to be the first asymptote, and this one in green is going to be the second asymptote. So let's write the pink one, right, which is going to be x minus 1 is equals to 0. Always for this one, always equated to 0. So you're going to take the 1 to the other side. So it's going to be x is equals to 1. So this is the first asymptote. Then for the green one, we're just going to say y is equals to the green part, which is y is equals to 2. Then question 5.2 says determine the intercepts of the graph G with x's, right? So we need to determine the coordinates, right? So for the y-intercept, right, what do we need to do? We need to let x equals to 0, right? So wherever here in the equation, wherever we see x, we're going to substitute by 0. So we're going to change this g of x and just make it y. So you're going to say y is equals to negative 4 divided by 0 minus 1 plus 2, right? Then punch this whole thing in your calculator, which you're going to get y is equals to 6, right? Then we're going to write in coordinate form. So for the x value, it's going to be this one, it's going to be this one, so it's going to be 0. Then for the y is the one that you just solved, which is 6. Then for the x-intercept, what you're going to do, you're going to say x-intercept, right? Then you're going to say let y equals to 0, right? So here in the function, at g of x, we're going to substitute 0. So wherever we see a g of x, we're going to substitute 0. So it's going to be 0 is equals to negative 4 divided by x minus 1 plus 2. Take the 2 to the other side, so it's going to be negative. So it's negative is equals to. Then this is the same as divided by 1. So what we're going to do is we're going to cross multiply. So it's going to be negative 2 multiplied by x minus 1. It's going to be equals to 1 multiplied by negative 4. It's going to give me negative 4. Divide both sides by 2 by negative 2. So here the negative 2's are going to cancel out. So you're going to be left with x minus 1. It's going to be equals to what? To positive 2. Take the 1 to the other side. So therefore x is going to be equals to 3. Right? Then we're going to write it in coordinate form. So it's going to be what? It's going to be 3. And for y, it's going to be the 0. Then the last question says sketch the graph g of x. Show all the intercepts with the x's well as the asymptotes of the graph. So when sketching a hyperbola, you need to know the following. So you need to know the following. You need to know the shape, right? You need to calculate the asymptote or write down the asymptote. And the third one, you need to know the intercept. So we already did this and we already did that. The thing that we need to determine is the shape. And to determine the shape, we use a, right? So when a is greater than 0, meaning that it's positive, this is how the shape is going to be. It's going to be in the first and third quadrant. And when a is less than 0, meaning it's negative, the graph is going to be in the second and fourth quadrant, right? So in our case, where is a? I'm just going to write it here in the question paper. Where is a? A is equals to what? Is equals to negative 4, right? Meaning a is what? Is less than 0, right? So meaning the shape is going to be where? It's going to be in the second and fourth quadrant. So now knowing that, we can actually sketch the graph. So I'm going to draw a Cartesian plane so that we can sketch the graph. So this is your Cartesian plane. So whenever drawing a hyperbola, you always start with the asymptote, right? So I'm going to do it in a different color. So your asymptotes are going to be what? They say x is equals to 1. Where is x? X is going to be here, right? Then you're going to just go down. Where? So you're going to go down to 1, right? Then you have y is equals to 2, which is going to be here, right? Then you're going to go like this. So now moving on to your what? Moving on to my intercept, we have 0 and 6. So for 0 and 6 is going to be where? It's going to be the y-intercept, right? So it's going to be here. Then we have 3 and 0, which is going to be our x, which is going to be here. here, right? Then remember the fact that to know how to draw it, you need to remember the shape. So we see the fact that the shape is between what? Is between the second and the and fourth quadrant. So let's draw it. It needs to cut here. So one of them is gonna cut here. So this is the first one, and the second one needs to cut here, and that's basically how your graph would look. So now let's do question 6. It said, sketch below are the graph f of x, which is a quadratic function, and g of x, which is a straight line. Then they say f and g, but they say f and g intersects at b, d, and then they say B, D are x and y intercept of G respectively. Then they say C is a turning point of F, V is a point on G, and N is a point on the x-axis such that CVN is perpendicular to the x-axis, right? Then they say E is a point on G such that CE is parallel to the x-axis, and AB are the x-intercept of F, right? So now doing the first question, they say determine the coordinate of C, the turning point of F. So we know the fact that f of x, right, is given as being this. So after f of x being given as that, we need the turning point, right? So since the since the function is in standard form of a quadratic, right? So what I'm going to do, I'm going to use this formula, which is x is equals to negative b divided by 2a. What do we need to use? What do we need to find? We need to find a and b, right? So a is this one. It's the coefficient of x squared. Since x is -1, this is the same as -1. So this is our a. Our b is the coefficient of x, which is this one. And c is the constant, right? So this is a, and this is going to be your b, and this one's going to be your c, right? So we need a and b. So we're going to substitute a and b here, which is going to be what? -4 divided by 2a, which is -1, right? And you're going to get your x being equals to +2. Right? Then you're going to take that value and you're going to substitute it for f of x to find the coordinates. So you're going to say f of 2 is equals to, wherever we see x, we're going to substitute by what? By 2. So it's going to be negative. If you punch this to the calculator, you're going to get, therefore, making your turning point coordinates being what? Being 2 and 9. Then you're done with the first question. So the second part says write down the range of f, which is f is the what? Is the quadratic, right? So to write down the range is determined by these two rules. So here are the two rules, right? For range, we need a and we need q. So when a is greater than 0, meaning in other terms that a is positive, then y is going to be what? It's going to be greater than and equals to q, right? Then for a less than 0, meaning in other words a is negative, y is going to be less than and equals to q. So in our case, right, what's a? We're going to go down and check what's a. We see that from the equation, right? A is equals to -1, right? When a is equals to -1, meaning it follows this rule, right? If it follows this rule, what's the next step? We need to find what? We need to find our q. Our q is from the turning point, right? This one is p and this one is q, right? So in our case, q is 9. So we know the fact that q is going to be what? It's going to be equals to 9. Then to write our range, therefore range is what? Range is going to be what? Y is less than and equals to what? To 9. Then you've done finding the range here. Then question 6.3 says calculate the length of AB. We need to determine where is AB in the graph. So AB is this one, is this point, and it's also this, the one in green, right? What can we see? AB, they even said it in the question, in the description, up in the question, they say AB are the what? Are the x-intercepts of f of x. So to calculate the length of AB, we need to find the coordinate of A and the coordinate of B first. So let's do that. So we know the fact that the x-intercepts, right, we need to let what? Y equals to 0. So at f of x, which is the same as y, we're going to let it to be 0. So it's going to be 0 is equals to. Then you're going to need to factorize this. So I already have videos on how I factorize. I'll link up the video about factorization. So before we factorize, what we're going to do is we're going to take the negative outside as being a common factor. So you're going to say 0 is equals to, take out the negative. So everything here is going to change its sign. So this one, which is x squared, since it's negative, is going to become positive, and this one is going to become negative, and the last one's going to become negative. Then when you're done, you can factorize the one inside the bracket, which is you're going to get. Then to get rid of the negative, we're going to divide both sides by -1, which is the negative and the negative are going to make a positive, and this side is going to remain as being what? As being 0. So it's going to be 0 is equals to, right? Then you have your 2 intercept, right? So the first one, you're going to equate it to 0. So it's going to be x plus 1 is equals to 0, which is the same as x is equals to -1. And the second one, you're going to equate it to 0 too. So you're going to be, or take it to the other side, it's going to be x is equals to +5. Then write it in coordinate form before we determine which one is A and which one is B. So let's do that. So it's going to be -1 and 0, and also here it's going to be 5 and 0. So we see the fact that A, right, is on the what? The negative x's. So this one is going to be the one with -1 and 0. And we see that B is on what? It's on the positive x's. So it makes sense that this one is going to be what? It's going to be 5 and 0. They say they want the length, right? So if this one is 0, if here, this is the 0 coordinate, from here to here, it's how much? It's going to be 5. It's going to be 5 units, right? Then from here to here, it's going to be what? It's going to be 1 unit, right? So 1 plus 5 is going to give us what? 6. So therefore, I'm going to write it in green here. So therefore, AB, the length is equals to what? Is equals to 6 units. And we're done with this question. 6.4 says determine the equation of G, which is the straight line, right? We know the fact that they gave us G of x as being equals to mx plus what? Plus c. So we need to find what? We need to find m and c. So first we need to find the gradient of what? The gradient of the graph, right? So what do we see here? We see the fact that, okay, the function f of x and g of x intersects at D. Let me do it in another color, which is red. It intersects at D and also intersects at B, right? And to find the gradient, we need 2 sets of coordinate. So we already have one set of coordinate, which is B. So we need to find another set of coordinate, which is D. What do we see? That we see the fact that D, right? What you call this D is the what? Is the y-intercept of f of x. So we're gonna first find the coordinate D using that is the y-intercept for f of x. So we're gonna say the y-intercept, right? Then we're gonna go up to the equation, right? When we go up to find the y-intercept, it's always going to be 0 and c if you have the function in this form, right? And what's c? C, as I said previously, the fact that it's going to be 5, right? So this is c. So your coordinates here is going to be what? It's going to be what? It's going to be 0 and 5. So here the coordinates are going to be 0 and, right? So we have already found our 2 sets of coordinate, which is D and B. So now finding the M, right? Which is the gradient. M is going to be equals to what? To y1 minus y2 divided by what? By x1 minus x2, right? So we need to determine between B or C which one is going to be 1 and which one is going to be 2. So I'm going to make A, B man 1. So I'm going to make a B 1 and I'm going to make D 2, right? So M is going to be equals to what? What's y1? Y1 is 0, so it's going to be 0 minus 5. And what's x1 is going to be 5 minus what? Minus 0. So therefore, making our gradient equals to what? Making our gradient equals to -1. So we have found M, now we need to find C. So to find M, you're going to take this function, which is going to say, I'm going to say y is equals to mx plus c, right? Now I'm going to substitute, you either substitute B or D, your pick, right? But I'm going to substitute B, right, to find C. So I'm going to substitute M, the one that we found, and I'm going to substitute B. So let's do that. So what's our y here? It's going to be 0 is equals to, our M is -1, then our x is going to be +5, right, plus c. Take this to the other side. This is the same as having what? A +5, right, which is equals to c. So that's going to be our c. G of x is going to be equals to what? It's going to be equals to -x, right, plus 5. And you're done with this question. So question 6.5 says T is a point on F such that D and T are reflections of each other over CV CVN, right? So this is the line of CVN. So this line, I'm just going to make it in red, right? The reflection. So this point is going to mimic the other one on the other side. So I'm just going to make it in green. So they're going to share what? First, they're going to share the same y-axis. So it's going to be here. This is going to be point T, right? Having what? Having the same y coordinate, which is going to be 5, right? Because just it's a mirror of D, right? Now we need to find what? We need to find the x value. So what can we see? They say write down the coordinates of T. So what do we see? We see the fact that from D, right? I'm going to make it in black. From D to this line where it mimics, where it mirrors T, right? We see the fact that from this point to this point, right? This is going to be what? It's going to be 2, right? Because of it goes from 0 then till 2. Because of the 2 is from where? Is from the turning point. You know the fact that this point is going to be 2. The x value here is going to be equals to 2, right? So now if this side is 2 and this are the same thing, it's just that a reflection, it needs to go another 2, right? If it goes another 2 and 2 is going to make it what? 4. So the point here is going to be what? It's going to be x is equals to, so here the coordinate is going to be what? The T value is going to be 4 and 5. So for 6.5, the coordinate T is equals to 4 and 5. So 6.6 says the line EC, right, which is going to be this line here. Just going to highlight it in green, this line. They say is a tangent at C. So you see the fact that it touches the turning point at C, right? That's why it's a tangent. So now they say 6.1 says write down the gradient of the tangent, which is the tangent is what? Is EC. So anything that is cutting horizontally, the gradient, if it cuts just the y-axis, the gradient is always 0. So just remember that gradient is going to be equals to 0. So in our case, m is equals to 0. Then 6.6.2, it says determine the equation of E. Where is E? Let me do it in red. Is here. You see this point? That's E, right? So we need to determine the coordinates there. How do we determine the coordinates? We see something. We see the fact that the graph, right, the line EM and what, and the f and g of x cuts there, they intersect there, right? When two functions intersect, right, we can equate them together. So let's do that. So we know that g of x is equals to what? Is equals to negative x plus 5. So now we need to find the equation of EC. So how do we find the equation of EC, right? This point, right, this 9 corresponds to this line. So here it's 9, right? So therefore, since it's just cutting the y-axis, that equation, right, y is going to be equals to what? To 9. I hope that makes sense, right? So you're going to equate this 2 together. This g of x is the same as saying y is equals to x plus 5, which we have y as being common, so you can equate the equations. So you're going to say 9 is equals to negative x plus 5, right? Take the 5 to the other side, so we're gonna have 9 minus 5 is equals to negative x. This side is gonna give you a positive 4 is equals to negative x. Then to get rid of the negative, you're gonna divide both sides by negative 1. So the negative and negative is gonna become a positive, and this side is gonna be negative 4 is equals to positive x. That's your x coordinates. Now we need to find the y coordinate. You're gonna take this and substitute it here in the straight line. So you're gonna say y is equals to, wherever you see x here, you're gonna substitute by negative 4. So it's gonna be minus 4 plus 5. Therefore y is gonna be equals to 9. So your coordinates here is gonna be what? It's gonna be the coordinates for E. It's going to be what? It's going to be negative 4 and 9. Then you're done with this question. So 6.7 says determine the value of k for which y is equals to negative x plus k is the tangent of f of x, right? So what do we know? We know the fact that the equation to the tangent of tangent f of x is what they gave us as being y is equals to negative x plus k, right? And we know that f of x in our case is equals to negative x squared plus 4x plus 5, right? So what do they want? They want k. What is k in a normal straight line equation? K is C. So what we need to do is we need to find the x and y point, right? The point where the gradient is equals to -1, right? So that's what we're going to do so that we can find k, because we know that gradient here of the tangent is what? It's -1. So let's do that. So the first part is we know that gradient, we know that f of x prime is equals to the gradient. So finding the first derivative is going to be f prime, right? It's going to be equals to negative. We're going to take the 2 in the front, so it's going to be x, then it's going to be 2 minus 1, then it's going to be plus, then 4 multiplied by 1 because we took the 1 in the front, so it's going to be x 1 minus 1, then the constant is gonna become 0. Then simplify this, so f of x is gonna be equals to negative. So since we're done finding f of x, we need to equate this f of x, the gradient, into the gradient that we already have, which is -1 from the equation. So this side is going to be -1 is equals to -2x plus 4. Then we're gonna solve for x because we're looking for 2 points, right? We're looking for coordinates. So we're gonna take the 4 to the other side because it's gonna be -1, -4 is equals to -2x. Then this one's going to be -5 is equals to -2x. So therefore 5 divided by 2 is going to be equals to x. So this is the x coordinate. We're going to take this x coordinate and we're going to substitute back where? To the original, which is f of x. So let's do that. So we're going to substitute it inside the original, right? When you substitute into the original, when you punch this whole thing into the calculator, you're going to get what? You're going to get 35 divided by 4, right? So making this point, let me just do it in green here, making this point 5/2 and 35/4, the point where the gradient is equals to -1, right? So now what we're going to do is we're going to find k, because we know the fact that they gave us an equation saying y is equals to -x plus k, right? So at that point we need a point, a coordinate, right? So we're going to substitute this coordinate here to find k. So it's going to be what? It's going to be 35 divided by 4 is equals to -5/2 plus k. Take this to the other side. It's going to give you, so simplify this, punch this into the calculator. You're going to find that k is equals to 45 divided by 4. And that's your k value. So now going to question 7, it says in the diagram, the graph h of x is equals to log ax is drawn. Then they give us that the point P is 0.5, comma, -1 lies on H, right? Then what is this? This is a logmetric, which is an inverse of what? Of the exponential graph. So the first one says determine the value of A. So to find the value of A here, we already have one set of coordinates. So we're going to use those set of coordinates to calculate for A. So 7.1, we know the fact that we have h of x is equals to, right? So what we're going to do is we're going to substitute this coordinate. So for y, which is h of x, is going to be -1 here. Then here it's going to be log A. Then what's our x? Our x is 0.5. So it's going to be 0.5. Then we're going to put this in exponential so that we can solve for A. So this one is going to be the A. Let me do it. A is going to be the base. Then this one is going to be the exponent. Then this one is going to be on the other side. Other side. All right. So let's write it. So it's going to be A to the power -1 is equals to 0.5. Then write this in fraction form. So it's going to be A divided it's going to be 1 divided by A. And this one is the same as 1/2. Then we're going to cross multiply. So it's going to be 2 is equals to A. So our A is going to be equals to 2. Then 7.2 says write down the equation f to the power -1, which is the inverse, right, of f of h in a form of y. So we know the fact that we have what? H of x, right, is equals to log. We're going to substitute the 2 that we got in the first part, right? So I'm going to write this h of x in terms of y. Then to find the inverse, we need to swap the x and y, right? So here's going to be x is equals to, then we're going to make what? Y subject to the formula. So we're going to do the same thing that we did for the same question. We're going to change this as an exponent. So as you know, the fact that the 2 is going to be the base, right? This y is going to be on the other side. Then this x is going to be the exponent, right? So it's going to be what? It's going to be 2 to the power x is equals to y. Therefore, y is equals equals to 2x. Then you're done with this question. So 7.3 says write down the domain of H inverse, right? Which is H inverse in our case. We have solved it. We say it's equals to what? To 2x. Since this is an exponential graph, you need to think about the notes of exponential, right? So is that the domain of what? Of an exponential graph is what? Is x is an element of x is an element of real numbers. So domain here is going to be what? It's going to be x is an element of real numbers. And this is the case for always. The domain for the exponential is always x is an element of real numbers. Then the last question says determine the value of x if h of x is what? Is less than and equals to 1. So we know the fact that h of x is less than and equals to what? Negative 1. So here on the sketch we need to find where is negative 1, right? So it's the y coordinate. So it's going to, we see the fact that this point P has negative 1, so this is the part, right? But they say that we need to write our answers in terms of what? In terms of x. So the coordinate here is negative 1, then it's y, its x is going to be 0,5 from here. So this is going to be 0,5, right? So they want the we want h of x, right, where is less than and equals to 1. Where is that portion? It's going to be here. So our answer is going to be between 0 and 0.5. So our answer is going to be what? It's going to be x is between what? It's between 0. 0 is not less than and equals to, because of 0 is the asymptote, but is greater, it's going to be less than and equals to 0,5. Now you're done with this question.